Most passengers on board that morning were asleep. It was a routine flight from Surabaya to Singapore. Some were traveling for work, some were heading home, others were beginning their holiday. Inside the cabin, everything felt normal, but far above the dark waters of the Java Sea, the aircraft was already flying toward a line of violent storms. And inside the cockpit, something unexpected began happening. The aircraft did not simply fall. First, it climbed. Far faster than a passenger jet should ever climb. Within minutes, AirAsia Flight 8501 disappeared from radar. What investigators later discovered was deeply unsettling. A modern jet, a functioning aircraft, a routine flight. That suddenly climbed itself into disaster. And once it began, there was almost no time left to recover. The aircraft was an Airbus A320. Short haul, highly automated, extremely reliable. There were 162 people on board. The flight departed Surabaya before dawn. Outside the windows, the sky above the Java Sea was unstable. Towering storm systems were forming across the region. Tropical convection, massive clouds, rising tens of thousands of feet into the atmosphere. Flights across Southeast Asia encounter storms like these every day. Pilots usually avoid them by adjusting course or requesting a higher altitude. AirAsia 8501 requested exactly that, a climb. Higher altitude meant smoother air and distance from the most violent parts of the storm. But air traffic control asked them to wait. The airspace above was busy. Another aircraft already occupied the requested altitude, so the A320 remained at 32,000 feet, flying toward a wall of weather. Inside the cockpit, the pilots monitored their radar, adjusting slightly left and right, trying to find a safe path between the storm cells. And then, a warning appeared. Not a dramatic one, not an emergency, just a small message on the display, a fault in the rudder system. The warning involved a component called the Rudder Travel Limiter Unit. In simple terms, it restricts how far the rudder can move at high speeds. The system protects the aircraft from excessive side forces, but this fault was not new. Maintenance records later showed the same warning had appeared repeatedly in the weeks before the accident, more than 20 times. Each time it had been reset. Each time the aircraft continued flying normally. So when the message appeared again that morning, it did not immediately seem dangerous. The crew followed the standard response: reset the system, continue the flight. But the warning kept returning, again and again and again, each time interrupting the cockpit workflow, each time demanding attention. Eventually, the captain made a decision, one that pilots almost never make in the middle of a flight. He reached behind his seat, into a panel most passengers never know exists, and pulled a circuit breaker. Pulling the circuit breaker cut electrical power to the faulty system. In theory, it would clear the warning completely. And for a moment, it did. But when power returned, something else happened. The aircraft's flight control computers reset. The autopilot disconnected. A chime sounded inside the cockpit. Suddenly, the aircraft required manual control. That alone was not unusual. Pilots hand-fly aircraft regularly, but the reset also changed something deeper. The flight control system switched to a degraded mode. Some automated protections were reduced. And at that exact moment, the aircraft encountered turbulence from the surrounding storm system. The aircraft rolled slightly. The pilot reacted instinctively. He pulled back on the side stick. Instead of stabilizing the aircraft, the nose pitched sharply upward, 10 degrees, 15, 20. The Airbus A320 began climbing aggressively. Vertical speed surged past 5,000 feet per minute. Air traffic controllers watching their radar saw the altitude rising rapidly. This climb was not requested, it was not coordinated. And at that altitude, such a steep climb carries a dangerous consequence. Airspeed begins to fall, lift begins to weaken. The margin between controlled flight and stall becomes dangerously small. Inside the cockpit, the pilots were now managing several things at once: manual control, weather avoidance, system messages, and a rapidly changing flight profile. The aircraft continued climbing. Then, the stall warning activated. In a stall, the wings no longer produce enough lift. The solution is simple in theory. Lower the nose, reduce the angle of attack. Allow the aircraft to accelerate again. But high-altitude stalls behave differently. The thin air provides less aerodynamic margin. Recovery takes time, and in turbulence the aircraft's motion can feel confusing and disorienting. The A320 reached its peak altitude, then the lift collapsed. The aircraft rolled sharply to the left. Bank angle increased beyond 90 degrees. The stall warning continued sounding. Inside the cockpit, the pilots attempted to recover, but the aircraft was now descending rapidly, not smoothly, but tumbling through unstable airflow. For several critical seconds, the aircraft's attitude changed faster than the pilots could correct. The nose dropped. The bank angle fluctuated. Airspeed indicators fluctuated as the aircraft moved through disturbed air. The pilots continued applying control inputs, but the aircraft had already entered a deep aerodynamic stall. At that point, recovery becomes extremely difficult. Altitude disappears quickly, and the margin for correction vanishes. Within less than a minute, the aircraft descended thousands of feet. Below them, the dark waters of the Java Sea were invisible. Moments later, the aircraft struck the ocean. All 162 people on board were lost. When investigators later recovered the flight recorders, the sequence became clear. The aircraft had not suffered a catastrophic mechanical failure. The engines were operating normally. The structure was intact. The weather was severe, but survivable. Instead, the accident emerged from a chain of smaller events: a recurring maintenance fault, a circuit breaker reset, a sudden change in flight control behavior, an aggressive climb, and finally, a stall. None of these elements alone guaranteed disaster, but together they formed a sequence that unfolded faster than the crew could fully interpret. Modern aircraft are designed with multiple layers of protection: automation, redundancy, warning systems, training. All of it exists to prevent a single failure from becoming fatal. But aviation accidents rarely come from a single failure. They come from alignment, small issues stacking on top of each other, until suddenly, the system crosses a threshold and the margin disappears. AirAsia 8501 was not destroyed by the storm. It was not brought down by catastrophic mechanical failure. Instead, it climbed into a situation that left almost no room for recovery. Because on that morning, above the Java Sea, the climb meant to escape the storm became the beginning of the fall, and once that climb began, there was no altitude left to save them.